Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 75, sort colors. This is a medium difficulty Leetcode problem, and we're told that we're given an array called nums with n objects colored red, white, or blue, and we need to sort them in place so that objects of the same color are adjacent with the colors in the order red, white, and blue. And we're told that to identify the colors being red, white, and blue, we'll use the integers 0, 1, and 2 to represent the color red, white, and blue, respectively. And we must solve this problem without using the library sort function. So this could be a really simple solution if all we did was run the built-in sort function for whatever language we were using. But of course, we can't do that because that's not how Leetcode works. And also, this is a medium difficulty problem, so we know there's going to be some twists and turns here. And they actually kind of stumped me when solving this problem initially, because you kind of think, how do I solve this? Should I use sorting? Oh, do I need to implement my own sorting algorithm? But really, this problem can be solved with a simple two-pointer solution. It's not so simple, it requires a level of intuition. But once you understand it, knowing that you can implement a two-pointer solution to solve this problem makes a lot of sense. And actually, it's not even a two-pointer solution, it's more like a three-pointer solution. So in this example, we're given 2, 0, 2, 1, 1, and 0, all, where we've got red, white, and blue, but they all are in different orders, they're all randomized in different positions in this list. And the output is going to be in order. So we've got red, white, and blue all in order. So we have the zeros where we want on the left-hand side, we want the twos on the right-hand side, and we want the ones to congregate in the middle. So how can we actually solve this problem? Well, like I said, we're going to have a three-pointer solution. So we're going to have 2 pointers. So we're going to have a left pointer and we're going to have a right pointer. And then we're also going to have a pointer that iterates through the list. So this is going to be our third iterative pointer. And what we're going to do is we're going to go through our list and we're going to say, if the number is 0, let's put it to the left-hand side. If it's at 2, let's put it to the right-hand side. And if it's a 1, we'll leave it as it is, and the ones will naturally congregate in the middle. So it'll make more sense as we actually solve this problem. But I definitely would reference other two-pointer videos of mine, or just using the knowledge from other two-pointer problems that you've solved. And then again, this problem solution will make a lot more sense. So the first thing we want to do, of course, is set our pointers. So we're going to have our left pointer, our right pointer, which is going to be equal to the length of nums minus 1. And then we also want our iterative pointer. And then what we want to say is while left is less than or equal to right, so while the pointers don't actually collide with each other, so to speak, before as long as they don't converge, as long as both pointers don't meet each other, we can carry on our while loop. And we want to say if the element at nums I is equal to 0, well, we can put it to the left-hand side of the list. So we can say nums I, nums L is going to be equal to nums L, nums I. So we're going to put all the zeros at the left-hand side of our list. We also want to increment our left pointer when we do this, and we also want to increment our right our iterative pointer. Otherwise, if nums I is equal to 2, well, where do we want to? Well, we want the exact same thing. So we want to basically just say, replace L here with R. So we want the element at I to be at the right-hand side of the list. And we want to decrement our right pointer now to free up another slot. But what about incrementing I? Well, this is the part that catches people out, and it definitely caught me out. We don't want to increment our right pointer. Why not? Well, we don't actually know what I is. I is unknown, so we need to check I. I could either be, either 0, 1, or 2. We have no idea what I is. It's unknown to us. So we want to still check I. So we don't want to increment I. We want to check I on the next iteration. And if we have 1, well, we're not going to do anything. We're just going to increment our I pointer. And yeah, that's all the code. So why are we just incrementing our I pointer for 1? Well, we don't actually need to do anything. The logic here will solve that. We put all the zeros to the left-hand side and swap in any ones will come in the center. The same goes for the second condition here. Any of the ones will congregate in the center. So naturally, we'll find that the ones end up in the center, the zeros on the left-hand side, and the twos on the right-hand side. And once this while loop is finished, we will have an answer similar to this, where we've got red, white, and blue in the respective orders. So let's actually run the code and check it passes all test cases. And we get an error because we have not indented this properly. So let's actually submit the code again. And we get the wrong answer. So there's clearly something wrong in the code here. If we look at the left pointer is equal to 0, okay, so while left is less than or equal to R, we are incrementing our left pointer and our right pointer. Okay. Okay. So if nums I is 0, okay, here is our problem. We're saying while left is less than or equal to R, when really we want to be saying while I is less than or equal to R. So while our I pointer is less than or equal to R, not our left pointer, there's not a chance that our left and right pointers will always meet. So we want to check, is our I pointer less than our R pointer? Because then obviously we can't do the rest of this logic here. So let's submit our code again. That was a mistake on my part. And now we can see we pass all 89 test cases with an optimal Leetcode solution. So in terms of time complexity, guys, this is just with 3 pointers. So it's just a single pass in essence. So we have an O of n, big O of n time complexity, and space complexity is going to be big O of 1 because we're modifying the list in place. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.